Okay, in this video, I'm going to go over inverse functions, and we're going to look at specifically how do we determine if a function has an inverse that is a function, and then we're also going to look at determining the inverse function algebraically. So in my class anyway, we talked about two graphs, y equals x squared, and we also talked about y equals x cubed, and we noticed here that when we graphed y equals x squared and then we graphed the inverse of that, looked kind of like this. And when we graphed y equals x cubed, the inverse kind of looked like this. And so what we noticed here was that this inverse, because of the vertical line test, try to get this vertical line here, was not a function because it crossed twice. Whereas the one down here, the inverse of x cubed, was a function because it does pass the vertical line test. Well, if we think about this over here, we've got something called the horizontal line test. And what the horizontal line test does is it determines if a function is called one-to-one. And that means for every x value, there's exactly and only one y value. In the case of y equals x squared, we'll draw a horizontal line, and notice that this horizontal line crosses at 2 points. Well, since this horizontal line crosses at 2 points, it means that there are two x values that give the same y value, namely here 1 and -1. So this cannot be one-to-one. Well, if a function is not one-to-one, then its inverse will not be a function. You see here, the vertical line test does not hold up. Whereas for x cubed, it does in fact pass the horizontal line test, which means its inverse is going to pass the vertical line test. Okay, so now let's look at how do we determine the inverse of a function algebraically. So what we're going to do is we're going to take, let's start with an example of, let's go f of x is equal to x cubed. And so we're going to find this function's inverse. So the first step is to change this f of x into a y. So we're going to make this y equals x cubed. The next step is we're going to solve this for x. So we're going to solve whatever this function is for x and then put it in terms of y. So in order to solve this, we're going to need to take the cube root of both sides. And so we're going to have the cube root of y is equal to x. Now that we've got x isolated, we're going to switch the x and the y. And if you remember in class when we graphed the graphs, we switched the x and the y coordinates. So we're going to switch the x and the y here, and we're going to get the cube root of x is equal to y. Lastly, we're going to take this y and we're going to change it to the inverse notation. So our final answer here is going to be f. So the inverse of f of x is equal to the cube root of x. And this is how we would find our inverse. So I'm going to have two more examples here. I encourage you to look at the example, try work it out using the same method I did here before I go over it, and then you can see how you did. So the next one, we'll do example 2, is going to be, we're going to have f of x is equal to 2 over x plus 1. Okay, so following the same method we did here, we're going to take this and make this a y. So y equals 2 over x plus 1. Then we're going to solve for x. So we're going to subtract 1 to both sides. We're going to have y minus 1 equals 2 over x. And then in order to solve for x here, I'm going to instead of we can multiply both sides by x, or we could just take the reciprocal of both sides. So we're going to have 1 over y minus 1 equals x over 2. Then multiply both sides by 2, and we're going to have 2 over y minus 1 equal x. So now that we've solved for x, we're going to switch the x and the y, and we're going to have 2 over x minus 1 equals y. And now we just change this to our inverse notation, f with the negative 1 on top, so that's inverse. The inverse function of f of x is equal to 2 over x minus 1. Okay, so then I'll do one more, and again, make sure you try it out on your own and see if you can see what you can do with it, and then you can try to try it yourself. Okay, so this will be example number 3. This time f of x is going to be the 5th root of x plus 3 minus 5. Okay, so we're going to go through the same thing we did for the other ones. So we're going to change this into y. So we're going to have y equals the 5th root of x plus 3 minus 5, and this minus 5 is outside the 5th root. Then we're going to add 5 to both sides, so we're going to isolate x. So we're going to have y plus 5 equals the 5th root of x plus 3. Then we need to isolate x here, so we're going to have to do something with this root. And so in order to get rid of this root, we're going to raise both sides to the 5th power. So we're going to have the quantity y plus 5 to the 5th power equals x plus 3, because when you do the 5th power, it cancels out. Lastly, we're going to subtract 3 here, so we're going to have the quantity y plus 5 to the 5th power minus 3 equals x, because we subtracted 3 to both sides. Okay, so now that we have x isolated, we're going to switch the x and the y. So we're going to have x plus 5 to the 5th power minus 3 equals y. And then we're going to change this into the inverse function notation. So f to the negative 1x, so what this means, the inverse of f of x, is equal to x plus 5 to the 5th power minus 3. And that's your answer. Okay, so that's how you do inverse algebraically, and I hope you got everything you needed. Okay, we'll see you soon.